Hi, and welcome to the third video on ion channels featuring anxiolytic, sedative, and hypnotic drugs. In this video, we're going to discuss GABA A receptor subtypes and the Z drugs. The objectives of this lecture are to be able to describe the subunit composition of the GABA A receptor and its significance to the drug action, relate the selectivity of the sedative hypnotic Z drugs to their pharmacology, know the clinical uses and limitations of the Z drugs, and be able to compare the benzodiazepines to the Z drugs. In the previous video, we discussed the structure of the GABA A receptors, the inhibitory synapse, and circuit inhibition. As a reminder, the GABA A receptors are made up of 5 subunits. However, to add to the complexity, each of the 5 subunits come in different forms. There are at least 6 different alpha subunits and 3 different beta subunits. The different subunit subtypes are very important for drug development and drug targeting, which we will discuss further in a few slides. First, I want to discuss an experiment that was published in Nature in 1993, where they investigated rats that were bred for enhanced sensitivity to alcohol. This line of rat is called the alcohol non-tolerant rat. So essentially, these animals were very susceptible to falling over after alcohol administration. The commentary that was published alongside the article was quite interesting and included the quote, "The rodent in question is the alcohol non-tolerant rat, a hapless animal that is highly susceptible to the impairment of postural reflexes by alcohol and benzodiazepines." What the researchers found was a point mutation in the alpha-6 subunit that conferred sensitivity to benzodiazepines and ethanol. Now, normally the alpha-6 subunit is not sensitive to alcohol and benzos, but a single amino acid change conferred sensitivity. The alpha-6 subunits are expressed in the granule cells of the cerebellum, which is a brain region that is involved in motor control. And this may be one reason that these rats fell over so easily from alcohol. Importantly, this study also showed that the GABA A receptors are a molecular target for alcohol, and that receptor subtypes can provide an additional tool to study drug specificity and develop more specific drugs. Another study that examined subunit mutations looked at anxiety-like behavior in mice. Here, point mutations in the alpha-2 subunit can eliminate sensitivity to benzodiazepines. So transgenic mice that express this alpha-2 point mutation were tested in the elevated plus maze. This is a test of anxiety-like behavior in rodents. So normally, rats and mice like to be in the closed arms more than the open arms, because in the open arms they are exposed and vulnerable. In wild-type mice that don't have the point mutation, benzodiazepine administration can increase the amount of time the animals spend in the open arms. So we interpret that as anxiolytic, or the animals are having less anxiety when they're in the open arms and spending more time in the open arms. In the point mutation containing mice, the benzodiazepine no longer produces an increase in the time spent in the open arm. So the anxiolytic effect of the benzodiazepine is lost. Researchers have now gone through the different alpha subtypes with a combination of point mutation studies and transgenic mice, and determined that different alpha subtypes play different roles in behavior. So the alpha-1 subtype is primarily responsible for sedation, amnesia, and anticonvulsant activity. The alpha-2 subtype of the GABA A receptor is primarily responsible for the anxiolytic effect and muscle relaxation properties. Less is known about the alpha-3 subtype, but it may be involved in deep sleep and synapse function. Alpha-4 and alpha-6 are normally insensitive to benzodiazepines. And importantly, the alpha-5 subunit is linked to some tolerance effects. So this brings us to the last and new class of drugs that we'll discuss, the Z drugs. These all start with Z or have Z in their name. So I would like you to know zolpidem, also known as Ambien, which is the prototype drug for this class. Z drugs, like benzodiazepines, act at the benzodiazepine binding site. However, they only bind and activate alpha-1 containing GABA A receptors. So these drugs are selective for alpha-1 containing GABA A receptors, whereas the benzodiazepines activate all GABA A receptors. Now, the Z drugs are chemically distinct from benzodiazepines, but they still potentiate GABA at this site, and they are still classified as Schedule IV drugs. Now, importantly, the Z drugs are used for insomnia only because they can't relieve anxiety at non-sedating doses due to the lack of activity at the alpha-2 subunit. In addition, there is limited, if any, tolerance, so no rebound insomnia or dependence occurs because of lack of activity on the alpha-5 subunit. There is a rare but highly publicized side effect from these drugs called sleep eating. So sometimes patients taking these drugs will raid the refrigerator without knowing it and then wake up and wonder where all their food went. However, this is a very rare side effect, and as a reminder, in 2005, Zolpidem sales alone topped $2.1 billion. So insomnia treatment is a very lucrative thing for the drug companies, and there were over 26 million prescriptions for Zolpidem written. So overall, this is a very safe and effective drug for insomnia. There are several Z drugs on the market, and they all have differences in half-lives and pharmacokinetics. These differences are major factors in determining drug effects on sleep onset, sleep maintenance, and any residual daytime drowsiness. Here you can see Zolpidem, which has a shorter half-life, which is useful for sleep onset, but not really for sleep maintenance. It also doesn't have any residual drowsiness the next day. There is now a modified extended release version of Zolpidem that has a longer duration of action and can help improve sleep maintenance for people who suffer from that type of insomnia. So overall, the benzodiazepines themselves have been largely replaced by the Z drugs for the treatment of insomnia only, because of the much better tolerance profile and side effect profile of these drugs compared to benzodiazepines.